All right, and here we are. Obviously, I'm not here today. Okay, I'm here, but I'm in a meeting this period. Okay, yeah. So congratulations. I will check your homework. We'll talk about homework tomorrow. Okay, but it's officially Cat Day. All right, congrats, you made it to Cat Day. It's a big day today. All right, and you'll see why it's Cat Day. I'll explain that later on. But our goals today, we're going to understand equidistant points and how to prove perpendicular bisectors. We're talking all about perpendicular bisectors and angle bisectors today as well. Okay, there will be a break today, and remember we have a partner request next Friday. We have new material today, and then one more day of new material. Then we're going to be practicing everything next week. Okay, what I want you to do right now, I want you to pause the video. All right, and if you haven't done this yet, go to Schoology, the Chapter 6 folder, and complete the end of semester reflection and our block day, the block day check. Okay, this is the first one just about just me getting a snapshot of you and the semester and asking you to reflect on how things went in my class and other classes as well. And this block day check-in is just it says it's graded, but I'm not putting it in the grade book. It's more just for me to see where you're at with everything that we've learned so far, and also for you to see how you're doing as well. Yeah, you don't have to put your device away when you're done, obviously, because you're going to need it to finish the video. Okay, so go ahead and pause it and do those two things. When you're done, come back to the video and go for it. All right, well, welcome back. Okay, we're talking about equidistant points. Equidistant points are exactly what they sound like. They're points that are equal in distance from another one. So if I look at this here, I can say that if by marking these two with these two tick marks there, that O and P are equidistant from N. Okay, if I were to mark, hopefully my pen will work. There it is. If I marked like this, okay, we could say C and D are equidistant from A and B. All right, they're equidistant points from those 2 points. Okay, there's other ways we can think about it. All right, this is all we're doing right now is talking about we're trying to get to a perpendicular bisector. Because if we have equidistant points, then that's when we have a perpendicular bisector. So another way you could look at it is like this. And hopefully now you'll start to see our cat. Our cat is back. Okay, there's the whiskers, and there's the mouth. And the tongue. Okay. Another way you could see is within a kite, where there's my ears and my whiskers. So if you think perpendicular bisector, I think equidistant points. I think, all right, I need some ears and some whiskers. There's always going to be 2 pairs of congruent segments. And I don't like the word always, but I'm okay using it in this sense. Okay, so 2 points are equidistant if they are the same distance from third and fourth points. Okay. In all diagrams above, A and B are equidistant from C and D. Okay. From endpoints C and D. Okay. So therefore, line AB is called the perpendicular bisector of our line. Okay. In this case, you would know that this is true if this happened. Okay, so I could say that B is equidistant from C and D, and so is A. All right, because it's connected by 2 congruent segments. All right, next page. Here we go. So equidistance. All right, equidistance. Perpendicular bisectors is part of 6.1. All right, the other part is our angle bisector. Oh, here we go. Perpendicular bisector. It's the line. It's exactly what it sounds like. It sounds like 2 things. Perpendicular, which we know what that means, and bisector, which we also know what that means. So it's the line that bisects and is perpendicular. Remember, this means perpendicular, upside down T, to a segment. Okay. So we say, like, if we want an if-then statement, or if we want our theorem, if 2 points are each, oh, buckets. Come on. There it is. Equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment. Okay, and we can talk about the converse too. All right, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. All right, so what does this all mean? How are we going to use this? Great question. Okay, here we go. So I'm telling you that D and DF is a perpendicular bisector to EG. So that tells me that D to E and D to G are congruent. There's my ears. And F to E and F to G are also congruent. Okay? That's what the perpendicular bisector gives me. It also gives me some right angles. So if I'm given that this is 8x plus 5 and this is negative 2x plus 15, well, these little tick marks mean congruence, so just set them equal. Go ahead and do that. Set them equal to each other and go ahead and solve. I'll do it here as well. Go for it. I'll pause it. Check your work. All right, so you got an x to be 1. I also want you to try the next example. Do the same process in number 2. All right, go ahead and pause the video, and then I'll show you my work on number 2. Okay, it's the same idea, except it's just laying on its side. The cat is taking a nap. Okay. Good night, cat. Go ahead. All right. Now, here we go. So I set those two equal to each other. All right. Now, I notice I have an x squared and only on one side, so that means I'm going to have to factor. So I'm going to bring everything to one side so it's equal to 0. I want two numbers that multiply negative 15 and add to 2. I got positive 5 and negative 3. So my x values are negative 5 and 3. Now, we got to test to see which one works. So if I plug negative 5 into this equation, I'm going to get a negative side length. So that's out. If I plug in 3, I'll get 30. So that is good. Okay, always test to make sure, because there will be a case where both will work. Maybe today. It's cat day after all. I don't know what that has to do with it, but, you know, it could have something to do with it. Cat. Okay, here we go. So next, now we're going to, change gears a little bit, but, keep it somewhat the same. So we're going to go review some writing equations of lines. Okay, if we want to write an equation of the perpendicular bisector of AB, first I'm going to plot my 2 points, negative 4, 2, that's A, and 6, negative 4, that's my B. Okay, connect my dots. All right, there. Okay, so now to do this, well, if it's a perpendicular bisector means it's going to do what? Split into 2 equal parts. So first I need to find the midpoint. And next I also need to find the slope. Once I find the slope, if it's perpendicular to AB, means our line is going to go through AB, right? I need the opposite. I'm going to write oppo. Reciprocal. I'm going to write recip. I don't have enough space. Of the slope. So let's first find the midpoint. Remember, to find the midpoint, I add my x values together and divide by 2, and add my y values together and divide by 2 as well. So I'll add -4 plus 6 and put that over 2. And I'll do 2 plus -4 and put that over 2. Well, -4 plus 6 is 2. 2 divided by 2 gives me 1. 2 plus -4 is -2. -2 divided by 2 gives me -1. Oh, look at that. It goes to that point. Okay? That's my midpoint. Step 1 is complete. Slope. If you can just count, here it's on the graph, so I might as well just count. I might as well just do my rise over my run. So I'm going down 1, 2, 3, 4, 5, 6. So m equals -6 over 1, 2, 3, 4, 5, over 10. And always reduce to get -3 over 5. That's the slope of AB. So the slope that I'm going to use, I'm going to look my perpendicular slope. M perpendicular is the opposite reciprocal. Remember, we flip it and change the sign. So now let's write the equation. Remember, point slope form. Y minus y1 equals m times x minus x1. x1, y1, y plus 1 equals 5 over 3 times x minus 1. Remember, this becomes plus 1 because I'm doing y minus -1. The two negatives make it a positive. All right. Let's use this same process, and I want you to try the next one, number 4. Okay. I will put up my answer. All right. But I want you to try it on your own. Go ahead. Check it out. All right. Check your work there. There's my midpoint, the slope of CD, and then my perpendicular slope was here. And there's my equation. All right, so we're going to change gears. We're going to talk about the angle bisector theorem. Okay, if a point lies on an angle bisector of, on the bisector of an angle, then it is equidistant from the points of the two sides. So if AD bisects this angle here, okay, and these two lines are perpendicular, then I can say that these two segments are congruent. Or conversely, if these two segments are congruent and we have two right angles, then I know that these two angles are congruent here. So if we look at number, I guess this is 4 again, all right, these two segments are congruent and these two angles are right. We want to find the measure of ABC. Well, if this is 56, then by the converse, this is also 56. So the measure of angle ABC is 56 times 2, which is 112. Similarly, if these two angles are congruent and we have two right angles, that tells me that these two segments are congruent, and that means I'm going to have to set these two expressions equal to each other. Now, remember, I want you to try and do this yourself. Remember what we talked about on Tuesday, okay, that this is not just x squared plus 4. You have to FOIL x plus 2 times x plus 2. Go ahead and try this. Go. All right, here we go. So here's my work. Okay, feel free to pause this as I go through it. All right, so I got x plus 2 times x plus 2, and then I combined like terms in my head to get x squared plus 4x plus 4. Moved everything to this side, so I have x squared plus 3x minus 4. Remember, two numbers that multiply -4 and add to 3, I got 4 and 1. So my x values are -4 and 1. Now, normally we'd throw out the negative, right? But we want to test it to make sure. If I plug in -4 here, -4 plus 2 is -2. -2 squared is 4. So that checks out. If I plug in -4 here, -4 squared is 16, plus 2 is, times 2 is 32, plus 7 times -4 is -8, 28. 32 plus -28 gives me 4. So the negative actually works. So both -4 and 1 are going to work. We always want to test to make sure it works in both segments. Okay, so I'm going to have two values for the length of JM, and that is okay. That is possible. All right, don't freak out. Your homework for tonight is on the online textbook. All right, it's there for you. Okay, go ahead and get started on that since you're finished with the video. Adios.